expect. The fourth one deals with ratios, where they will say you have a force F. What will happen to the force if I increase, let's say I double the masses of the objects? What will be the influence on the force? So that is a ratio kind of question. I don't provide you with specific information, but it's just a simple ratio kind of question. And let's start off by looking at one of them. So that would be the fourth kind of question that you can expect. If you look at the next page, example 2, and like I indicated, that's the fourth kind of question that you can get. Normally, we do ask this as a multiple choice question, which is very nice to ask, and you will see it in many of the old question papers. Let's look what they say. Suppose I have two objects, mass 1 and mass 2, and they are a distance d apart. And let us assume now that this distance d is between their centers. Determine how the magnitude of the force will change if both masses are doubled and the distance between them is halved. All right, so both the masses is doubled. So what was the force before I made the changes? The force was directly proportional to m1, m2 over d square. You could also have just written your normal formula, which you have g m1, m2 over d square. That's fine. Because normally when it's a multiple choice kind of question, you don't need too much to worry too much about how you write it out, because it's normally how we do ask this question. All right, then you can see the mass was now doubled. The other mass was doubled, and the distance between their centers was halved. So this is the changes that we made now. Now when I put those changes into my formula, you will see the mass is now 2m1, the other mass is now 2m2, and the distance is halved. But I must remember, according to my formula, this must be squared. All right, so if I square that, then I can see the total effect would be now 2 multiplied by 2 at the top gives me 4 times the mass 1 multiplied by mass 2. And if I square a half, it is now a half multiplied by a half, which gives me a quarter. All right, so 4 divided by a quarter, and you can do it on your calculator if you want to, will give you 16. So you can see this part, that was represented by F. So now I can see that F will be 16 times greater. All right, so what will the question look like? It would have given you A maybe of F, a B of 4F, a C of 8F, and D would have been 16F. And then U would have said, all right, this is D. So it's a very nice multiple choice kind of question to get. All right, let's look at one more. All right, what do they change now? They say the mass of M1 is doubled and the distance is also doubled. So one of the masses I'm doubling and also the distance between them. So let us just go back to my example again. So mass 1 was doubled. Mass 2 stayed equal to mass 2. That was not changed. And then D was also doubled. Now if I go to my formula, I'm changing mass 1 to 2 times that. M2 stays the same. And in the place of D, it's now 2D. Now when I look at this, at the top I have 2. At the bottom I'm squaring that 2. So that will give me a 4. And 2 divided by 4, that will give me a half. So it will now be half F. All right. So again, you will have your A, B, C, D, and you can then indicate that the force was halved by doing those changes. All right. So this is the fourth kind of question that you can expect. Let us recap quickly. All right. We said definition is a real possibility. Calculation kind of questions is a possibility. Working with graphs is a third one. And then working with ratios. This example 2, it gives you ratios. Not real value, but ratios. Okay, so that's a kind of question that you can expect. Let's look at the example where you need to do a calculation. I'm now on page 1.14. Okay, so if we go to example 1, very simple, and I really feel that our learners can get their marks in this section. You should do well in this question because you know exactly what to expect and you know your formula that is applicable. If you look at example 1, they say determine the gravitational pull. Right, so that word pull is just something else for the word force. So I know that I'm going to calculate F. That's what is the question. Between the Earth and a man with a mass of 70 kgs. So that is the mass of the man, so I've got my one mass. And then they say he is on sea level. And then the second question is he is in an aeroplane 10,000 meters above the surface of the Earth. Right, and then some more information that they give me. So let me just indicate the information that was given was 70 kilograms. They tell me the mass of the Earth is 5.98 multiplied by 10 to the 24 to the power 24. It's a big mass, that of the Earth, compared to the man. All right, and then they also give us the radius of the Earth. So I know on the first example that the man is on the surface of the Earth because he's at sea level. Means he's on the surface. So the distance between their centers should be the radius of the Earth. So I've got my value that I will substitute in the place of D. And now you can see that there they have substituted in the place of D, they have substituted 6.38 times 10 to the power 6. So you can see that this value was done, D, and they square it. There you can see they square it. All right. So this value, the unit in which we measure it, is meters. All right. Very important. Then if you look at our mass, that is mass 1, which is the mass of the man, 70 kgs. I substituted that there. And there is our second object. That is the mass of the Earth, which was the value that was given there. Right, and again, the unit in which I work is kg, kilograms. So if the examiner wants to check your knowledge, he might give that value to you in grams. It's a possibility. Then you will have to convert to kilograms. This might be given to you in kilometers, and then you will have to convert to meters. So that's something to remember when doing these substitutions. Then where did I get the 6.67 times 10 to the power minus 11? That is the value of G, and I got that from my data sheet. All right. So, and then I will get the answer if I work it out on my calculator, and please practice to be able to work with these powers and where you have to square them and things like that so that you can get the correct answers. You can practice it with this example very nicely until you understand how to work with your calculator. All right.